Alright, hello once again, Jeff Scott of Rankin Technical College, and I've been going over the PowerPoint presentations for our textbook for the AWD1100 Programming Fundamentals with C# class for the spring 2018 semester. Our book is Microsoft Visual C# 2017 An Introduction to Object-Oriented Programming by Joyce Farrell. We're on Chapter 5 of 14. Our objectives here, basically like most other programming languages, C# comes equipped, so to speak, with 3 different types of loops. Those types of loops being a while loop, a for loop, and a do or a do-while loop. So we'll discuss all of those. Then we'll get into nested loops, accumulate totals and accumulators, understand how to improve loop performance, and appreciate some of the issues involved with looping. A loop is one of the 3 hallmarks of structured programming. Structured programming is the ability to solve any problem using a combination of sequence, which means one line right after the other, selection, which is what we did in the last chapter with if, else, and switch, and repetition, also known as looping, also known as iteration. So with a loop, as it says there, it allows you to repeatedly execute one or more lines of code. That one or more lines of code that you repeat should be within curly braces, and that's what's called a block of statements. Now, loops use a Boolean condition to determine whether or not they should continue or whether or not they're finished. All right? Each loop execution is known as an iteration. Now, before we even do that, let's very quickly look at all 3 of the loops. So, I'm going to keep it simple. I want to count to 10. So the first loop we're going to look at is a while loop. So I'm going to say int LCV, which is short for loop control variable, equals 1. While LCV is less than or equal to 10, system.out.println, the value of LCV is now if I just printed that, just put that in because I have to put in one more line of code, that would say the value of LCV is 1, and actually it would just continue to say that, because I would be stuck in what's called an infinite loop, etc. So it would just keep printing that. All right, why? Because when you have a loop, you've got to have a way to make it end. So I'd have to say here something like plus plus LCV. Then what that's going to say pretty much what you think, and that is the LCV is 1 through 10. So let's look at this. This is called a pretest loop. All right, meaning that you test the value of the loop before you get into the body of the loop. There's 3 basic steps in any kind of loop. Number 1, you initialize the loop control variable. Number 2, you test the loop control variable. And finally, number 3, you change the value of the loop control variable. And I've done all these. Now this is called a pretest because imagine for a second here that I did this. I typed in there 11. Well, 11's not less than or equal to 10, so it would skip and it would not print anything. All right, I'm going to keep this here. And in fact, I'm going to copy it so I can show you the other 2 types of loops. All right. put a little bit of a barrier between these. And I'll paste that back in. The next type of loop that we'll talk about in just a moment is what's called a for loop. Now, some people like the for loop because it results in less code. And it results in less code because, as you can see, we initialize the loop control variable, we test the loop control variable, and we change the loop control variable all in the same line of code. So, here when we did it, we had 1, 2, 3, 4, 5, 6 lines of code, 1, 2, 3, 4 lines of code. All right, so let me grab this one more time. Just like the while loop, this type of loop is known as a pretest. Because again, had this value been 11, I would never have gone into the loop body to begin with. All right, so let's look at the last one here. All right, what I'm going to do is I'm going to grab this line of code. I'm going to stick it at the end this time. All right, I've still got my loop initialization. I still have my test. And I'm still changing the value of the loop control variable. The difference is I'm changing it at the end. So even if this was 11, this would print out the value of LCV as 11, then it would get out of the loop. This is called a do loop or a do while loop, and it is a post-test loop. You are guaranteed to run through the body of the loop at least once because you don't test it till the end. So we saw a while loop, which was a pre-test loop. Initialize, test, and change. We saw the for loop, which was another pre-test loop, which did the initialize, test, and change in one line. Pre-test, pre-test loop. And then we saw the do while, post-test loop, but still, initialize, test, change. All right? So you can use any of these. Sometimes the question arises, well, which one's better? And there really isn't an answer. Most people tend to not use the do while very often. All right, so here's how it looks programmatically in a flowchart. Again, it gives you the chance to continue as many times as you want. So we did the while loop. Again, what you test in the while loop, remember our while loop was while LCV less than or equal to 10. That's a Boolean condition. So the loop executed as long as that condition remained true. You saw that the while loop consisted of the keyword while, the Boolean expression, which has to be within parentheses, and the loop body. If there's only one line in a while loop, you don't need the curly braces. If there's more than one, they must be there. I'd recommend always putting in. Always putting that in. All right. And an infinite loop is one that never ends. Let me show you one thing though. Sometimes I go over this with people, sometimes I don't. But I'm going to grab this first one that we did right here, this one, and I'm going to basically just paste it back up here at the top. All right, now you might look and say, well, why are you doing that? Well, what I'm going to do is this. I'm going to say while LCV plus plus is less than or equal to 10. If I put that in there, I'm putting my changing the value here. So now I can cut a line of code off. So now 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. You know, I've cut one line of code off, still not as many as 1, 2, 3, 4, but a little nicer. All right. And I guess I could even go back down here and do this, where we did this one down at the bottom. So I could come in here and say while LCV plus plus is less than or equal to 10. So again, I could remove that line. So there are always ways that you can tweak your code to make it run a little better. I will tell you that virtually all the time you will see this written like this. Now, are there, is that true 100%? Of course not. In fact, professional programmers would probably write it the way I showed you here. Right? It just depends. And again, like anything else, it's a matter of personal taste. All right? Okay. As it says there, to make a while loop end correctly, 3 separate actions should occur. The variable being initialized, tested, and changed. I've already seen that several times now. Here it is in a flowchart. I'm not going to go over many flowcharts in here. All right. Here, this is going to write hello 5 times. Oh, I'm sorry. Started it at 1 and while it's less than 5. So write it once. Number is 2. Write it again. Number is 3. Write it again. Number is 4. Write it again. Number is 5. The test fails, so you fall out. If I wanted it to write 5 times, I could say less than or equal to limit here. Okay, or I could have started that at 0 and left it the way it was. Always a lot of different ways that you can do this. Here it's showing you that if you don't put in the curly braces, this isn't going to work. It's going to write hello once, and it's going to do this regardless, and you're not in a loop. All right. An empty loop is a loop that does not have any body. It just has curly braces. All right. We talked about incrementing. If I wanted to go backwards, I could also decrement. So in other words, if let's say that I wanted to count down from 10 to 1 instead of counting up. So let's look at that, and we'll grab this. We'll do this. Let's just copy this down. So we could have started LCV at 10 and said while it's less than or equal to 1, all right, and then here we would have said LCV minus. So we would have said here 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay? That would need to be curly or semicolon. Here we go. That would work just fine. Or again, instead of saying, we could have done the minus first, or we could have said LCV equals LCV minus 1, or we could have said LCV minus equal 1. Any of those would have worked. All right. Now, sometimes you don't know how many times you're going through a loop. You've got what's called an indefinite loop. The ones we've looked at so far have been definite loops or counting loops. With an indefinite loop, that's kind of like, imagine you've got somebody who says they're going to be, I'm going to be bringing you a bunch of tests over for you to grade. And you say, how many? You go, geez, I don't know. And some people are still taking them. So I would say you'll keep bringing them all over until, let's say that the last test, when you're all done, you bring one that's blank. So while the value of the test is not blank, all right, you keep going. That's a sentinel value. Okay, so here we're asking the user, do you want to see next year's balance? And if you say anything other than a Y, an uppercase Y here, you'll be done, and it'll say have a nice day. But if you say uppercase Y, all right, then it'll show you next year's balance. So there you go. The for loop, again, is a counting loop. When we looked at those indefinite loops a minute ago, like this one, you can't do this kind of loop with a for loop. A for loop needs to know when it's starting and when it's ending. All right? Other than that, using it is very much like using a while loop, except that, again, you do the initialization, the test, and the change, all right, all in the same line of code. That change is known as the step value. All right. If I come in here and do this, they're mentioning this about out of scope, and I just want you all to realize this, that if I run a for loop, let's grab our for loop, it's in here, there it is. All right, if I try doing this, if I say the value of LCV is, you might think, well, it's going to print out 11. No, since I'm creating the variable LCV, it only exists in between the curly braces. If I try to come in and print the value of the variable outside of the curly braces, I actually get an error. So this results in an error. And that's with any of the loops. If I create a variable in here, notice the variable is created out of here. So now I can put this in, and it'll say the value of the LCV is 11. I can do that here, or I can do it here, because I've created the value both times there and there. I've created it outside of the loop, where here I created it inside of the loop. When a variable is declared inside of a loop, again, it can be referenced only inside of that loop body. That's its scope. So when the loop body ends, anything that you declared in the loop body block is considered to be out of scope. Now, when you do this, and this is all in here, you must have, when you write a for loop, you must have two semicolons. If I wanted a loop to run forever, I could write this. That's an infinite loop. If for some reason I wanted to, if I wanted to say int LCV equal 1, then in that case I don't need to do this line. So I could just leave that blank. That's totally legit. Totally legit. All right, if I never wanted to test, I could leave that blank. You're almost always going to, unless there's a reason for something to run forever. And occasionally there is. All right, I worked on code years ago, back before the phones that we have now, back in the old rotary phone days, that I worked on code that you wanted to be able to pick up a rotary phone and get dial tone 24/7. So we had our code in an infinite loop. All right, but more often than not, when you've got code in an infinite loop, it's because you made a mistake. So the do loop is the post-test loop. It always checks at the bottom, so you always go through it at least once. So there was a while loop, and we could do the same thing with a, instead of a while loop, with a do while. All right, nested loops. I'll show you my favorite example of working with nested loops, and it's nothing fantastic, but it's kind of cool. Let me grab that for loop, make it a little easier for myself here. Paste that in. That's what I want to do. All right, so I'm not going to worry about comments or anything, but I am going to do this. I'm going to call this hours. Start it at 0, and I'm going to say while it's less than 23. I'm going to write myself a quick little military clock. All right. And oops, then I'm going to put this in again, but I'm going to change it a little, and you'll see it in just a moment. This will be minutes. And that had to be less than or equal to 23. And this will be less than or equal to 59. And then finally, I'm going to copy this. And this will be seconds. All right, and I will grab this. I'll need my curly braces. All right, what I've done in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines of code, is that's going to print out basically a clock. All right? And I should just say the time is. How about that? The time is, and I'm going to put in here, not LCV, but I'm going to put in here hours plus a colon plus minutes plus a colon plus seconds. All right? So that's literally going to print out time is 0, 0, 0. Time is 0, 0, 1. I'm not going to keep going, of course. Let's just say dot, dot, dot. Finally, time is 23, 59, 59. And if you can understand that, you understand how to use loops. This says, while this is 0. So this is 0, this is 0, and this is 0. So I print that out, 0, 0, 0. Then I add 1 to this. All right, so now it's 0, 0, 1. This goes all the way down to time is 0, 0, 59. Okay, then it's not less than or equal to 59, so I pop back up to this one. So now it's time is 1, 0, 0. And eventually, okay, so again, I just would put here dot, 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 just to show that there's something there. All right, so eventually, I'm going to go past 59 minutes, so I'll have time is 59 minutes, 1 hour, 59 minutes, and 59 seconds. So I'll come up and I'll say time is 2, 0, 0, etc. So what I'm saying is run this as many times as you can. Once that goes out of scope, increment this and run that. And keep going, and eventually this goes out of scope, then increment this. So with 10 lines of code, I can write myself a complete clock. That is a for loop, which is within a for loop, which is within a for loop. The reason I showed you that is those are nested loops. So as it says, when you nest loops, each pair contains an inner loop and an outer loop. All right, and that's exactly what I just tried to show you. Here's a different example. So what if I was writing a calendar and I could have a loop on the outside that went through the months and then a loop on the inside that went through the days. So I could have January 1st, January 2nd, January 3rd, all the way through January 31st. That would go through that inner loop, then I would pop out to the outer loop and add one, so I'd have February 1st, February 2nd, etc. All right, another example that they gave in the book. All right, let's talk about an accumulator. And let's suppose for a second that what I want to do, is I want to add up all the numbers from 1 to 10. All right, so I'm going to come up here and I'm going to say int sum equals 0 for int LCV equals 1. We'll start it at 1. LCV, let's say we want to see what all the numbers from 1 to 100 are equal. So while it's 1 and while it's less than or equal to 100, LC plus LCV. All right, now here I'm going to say simply one line of code, sum plus equals LCV. And then when I get done, I'm going to say system.out.println, the final total is plus sum. Now I could be wrong, but I think when you add all that up, it's going to come back and say something like the final total is trying to remember what it is. It's like 5,050 or something like that. This value right here is an accumulator. So this line right here is like saying sum equals 1 plus 2 plus 3 plus 4 plus ... if you'd imagine, all the way to plus 100. So sum is what's referred to as an accumulator. All right? Garbage. A garbage value is an unknown value. Okay? Let's see if we have an example here of a garbage value. Well, we've got total right there. That we are using it. We're using that 0 right there. All right, this is a quit value, so if you put in 0 for a purchase, you're done. Not sure exactly why they're doing that. But. All right, improving loop performance. Make sure that the loop doesn't do any more work than it has to do. Consider the order of evaluation for short circuit operators. Remember, when you're using not, and or. All right? It doesn't even have to be that. When you use common sense, let's suppose that I worked at a 4-year school. And in that school, 75% of my students were freshmen. All right? Let's say 70% were freshmen. 10% were sophomores, 10% were juniors, and 10% were seniors. All right? Then when I would be doing my checks, I'd want to check first for freshmen, because that's going to happen 70% of the time. Use prefix rather than postfix. So in other words, that's why I tried to show you here. Use the plus plus LCV instead of LCV plus plus, because it runs faster. Not sure exactly why. It has to do with the way that the computer works internally. Don't do this. While x is less than a plus b, all right? Because it's got to calculate that every time. But if I say here in sum equal a plus b, and then I say while x less than sum, here it's doing it 1,000 times, here it's doing it once. Again, use common sense. Remember that ands come before ors. So you take, with an and, you take the condition that's most likely to be false and you put it first. With an or, you take the condition that's most likely to be true and you put it first. All right? Loop fusion, they're saying here, it's combining 2 loops into one. Sometimes that works, sometimes it doesn't. That's the kind of thing that you learn by doing. You don't learn by seeing examples. Again, as we mentioned, plus plus x runs faster than x plus plus. So you use prefix rather than postfix. They're showing an example here where they hook it up to the system clock to show you the difference. All right. Issues in GUI programs. Using a loop within a method in a GUI is no different than a console. Event-driven programs can sometimes require fewer loops because, again, typically programs that aren't GUI are truly event-driven. You want a lot of stuff to happen. But with event-driven programs with a GUI, they're more user-centric. All right? So you'll notice here, how many greetings do you want? They put in a 5 and it says hello 5 times. We could have put in 100 there and it would have said it 100 times, etc. You want to see your balance? Well, ideally, do you want to see it once or do you want it to go through 5 times or whatever? It's all a matter of how you code it. All right? So to summarize, as it says here, use a while loop so that program execution runs continuously while a condition is true. Using a for loop, remember with a while loop, it can be used with a sentinel value or a counting loop. For loop is counting only. You initialize, you test, and you change all in the same line of code. Any one of these is optional, or all of them. Any 1, 2, or all 3 are optional. The do loop checks at the bottom, so you go through it at least one time. You can nest loops to get your desired results. Remember what an accumulator is? It's a total, basically. We talked about ways to improve loop performance. and the fact that typically, if you're going to use while for and do while in GUI programs, they're going to work the same way that they do in a console program. As always, I'm going to grab that slide. Open up Chapter 6. Did I put it in yet? Yes, I did. No, I did not. All right, and this is Chapter 6. And Chapter 6 is entitled Using Arrays. So I will grab that code, put it in here. All right, and I will be back to go over Chapter 6 in just a couple minutes.